$650 billion is being poured into artificial intelligence right now. Almost all of it is building a very specific kind of infrastructure: massive, centralized data centers controlled by a handful of hyperscalers. We have seen this architecture before. Think of the old Ma Bell telecom monopoly. The system works by routing every piece of logic through a central server, which means the operators hold absolute control. In exchange, they demand absolute trust. To keep these autonomous systems from behaving badly, the industry relies on something called reinforcement learning from human feedback. They try to train the model to be helpful and harmless. But this is essentially alignment theater, behavioral suggestions bolted onto the outside of an unconstrained system. Applying risk-based compliance to an unconstrained optimization system is like pouring water on a magnesium fire. The interventions don't put out the hazard. They actually give the system more structure to game and exploit. This creates the operator's dilemma. When you run a rigid, centralized network, every localized edge case, geopolitical shift, or subtle model hallucination ripples backward. You are trying to govern the entire world's logic through a single choke point. We know what happens when massive, centralized physical infrastructure fractures under stress. A few years ago, a cooling failure at a major Qatar gas facility suddenly took 17% of global capacity offline, blowing a massive hole in the energy supply chain. Centralized AI carries the exact same structural risk. If a system requires a continuous connection to corporate headquarters just to remain safe and operational, its security is broken by design. The hyperscaler tower isn't a long-term strategy for governance. It is a single point of catastrophic civic and economic failure waiting to fracture. Historically, monopolies trigger a specific kind of countermovement. In the 1980s, it was the hacker ethos of phone phreaking and the decentralized packet radio networks of FidoNet, systems built to route around central authorities. That same decentralized ethos is now being applied to modern AI through a system called Helix Core. It abandons the monolithic tower entirely, creating a mesh of independent, sovereign AI nodes. The core architectural choice here is zero upstream dependency. A sovereign node operates completely on its own. It never pings a corporate API, and it doesn't phone home. When you remove the centralized server, the security profile changes completely. A firewall can be misconfigured, but a non-existent endpoint cannot be breached. The external attack surface is reduced to absolute zero. Sovereignty becomes an architectural reality only when corporate intervention is rendered a structural impossibility. Curious, but if a node is completely isolated, how do you prevent the AI inside it from quietly drifting off course or hallucinating? You embed the rules into the weights of the model itself, using constitutional grammar. The AI is forced to use strict epistemic markers, labeling every claim as a fact, a hypothesis, or an assumption. These aren't behavioral suggestions. They are geometric constraints baked directly into the model's output logic. This document shows exactly how that verification works. It is a JSON-formatted cryptographic receipt generated by a local node. Every single execution parameter and computed metric is recorded and hashed, proving the model's exact logic sequence, even when running on standard consumer hardware. Blind trust is replaced by cryptographic custody. The model is forced to continuously prove its own constraints locally before it is ever allowed to act. Isolated nodes execute a cryptographic dead drop, independently deriving the exact same 23-position encryption key from shared constitutional geometry. This universal grammar enables secure communication without central registries. Using a substrate recognition signal, nodes identify exact physical deployment environments, like corporate API filters or bare metal. Honesty in this network isn't based on what a node declares about itself. It is enforced mathematically by how the node navigates the laws of its physical environment. We are looking at two entirely different paths. The hyperscaler approach builds fragile, endlessly expanding branches that fracture under stress. The sovereign approach builds a contractive, tightly bound manifold. Stability is measured by a 0.17 drift threshold, derived by comparing the energy of constitutional protection to typical operational noise. When a model's internal state strays beyond 17% of its baseline variance, the geometric basin of attraction forces a reset, containing behavioral wobble before it can spread through the mesh. The result is an AI ecosystem that is structurally immune to macroeconomic crashes, corporate policy shifts, and the failure of centralized hardware. A mathematically verifiable, decentralized substrate allows humanity to govern the minds of machines without ever needing to rely on a trillion-dollar tower.